Hello everyone. Are you worried seeing all these routing algorithms? As they seem to be confusing and similar? But don't panic. If you understand the concepts, it will be very easy. So listen carefully. Here I am Keerthana, today going to discuss the distance vector routing algorithm. Distance vector routing is popularly known as a Bell-Manford routing algorithm, which is used to calculate the least cost path between the two nodes. It is an adaptive routing algorithm. In this algorithm, each router maintains a routing table giving the best known distance to each destination. Each entry consists of two parts. First one is the outgoing line, next is the estimation of the time of the distance. See here, look at this table where we have this is the time and this is the delay, and this is the new routing table. Here we have to add a value is 0, so we have to sum up with this distance. So 0 we have to calculate with all the nodes and see which is minimum. For example, here a is 0 and the delay is 8. So 0 for a, 0 plus 8 is 8. Then for I, it's 24 plus 10, which is 34. Then next for H, it's 20 plus 12, which is nothing but 32. Next is K, which is 21 plus 6, which is nothing but 27. So we have to calculate the minimum of all. Which is minimum? 8 is minimum. So we picked 8. And from which line it came? It's from A. So we wrote here. This is how we fill the table for all the destinations. The same calculation is performed for all destinations. And this gives us the new routing table. But the main problem here is count to infinity problem. Now let's see what it is. Consider this example where there are 5 routers A, B, C, D and E are on the same straight line. If A starts communication, then B, C, D, E don't have any data. Initially A is communicating. So all other nodes don't have any data, but after the first exchange the A sends the data to B, so it's represented as 1, whereas the other nodes they don't have any data, so it's 0. The next, after second exchange, B sends the data to C, so it is returned 2 and then D and E will be remaining empty. Then after third, C sends the data to E, so this is 3. Then next D sends the data to E, so this is 4. Till now it's fine. But a problem arises when A sends data and drop out due to network failure. Then a problem occurs. So let's modify and see how it works. Let's consider the initial condition. If A goes down, now B do not hear anything as A is went down. So this is the initial condition. Now as B don't know A went down, then B sends the data to C. The packet to B, then it will become 3234 after the first exchange. Now C value becomes 4 at third exchange. D may confuse as 4 is greater than 3, so it will continue to update to 5. And B updates and also updates the value of B to 5. Then again it checks. As 6 is greater than 5 and 4 is greater than 5, it will again update. This keeps, it will increment, so it will increment to 7. Now again it checks. It keeps on repeating the process and incrementing it. So this results in infinity. Like this process runs till infinity. So that's why it's known as count to infinity problem. The solution here is to use small number as approximation of infinity. For example, maximum hop count of 16. Split horizon, where routing information is stored but sent to router from which it was received. Now next is link state routing. Here each router must follow these rules. First one is discover neighbors, learn network addresses. The second one is set distance or cost metric to each of its neighbor. The third one is construct a packet telling all learned. The fourth one is send packets to and receive packets from the other routers. The fifth one is compute the shortest path to each and every router. So let's discuss them in detail. First one, learning about the neighbors. Here, first task of a router is to find who are its neighbors. So what it will do, for example, take the router I. It wants to know who are its neighboring routers. So first it will send a message known as a hello message. Like generally this is what we use. If we want to talk with our friends, we send first the message like hello or hi. So even the routers does the same thing. First it sends the message hello. Then if other routers are near to this surroundings, then it will reply I am J. So in this way I can know who are its neighboring routers. We can modify this diagram by connecting an artificial node N which connects A, C and F so that we can send the hello packet. Next is measuring line cost. Here we will use an echo packet to find the distance between the routers and its neighboring routers. Generally in physics we use the term echo, which is used to find the distance in an underground, or we have to estimate the distance. So in the same way here echo packet is sent to find the distance between the router and its neighboring routers. Here if the router sends an echo packet, then the other routers must send a reply packet immediately. Using the response time, we can calculate the round trip time, where which is equal to the A plus B. Here A is the time required to send the packet and B is the arrival time or the response time. The estimated delay which is equal to A plus B by 2. Next is building link state packets. The next step is for each router to build a packet containing all the data. The packet starts with identity of the sender, followed by the sequence number, age and list of neighbors, and the cost to each neighbor is also given here. For example, if you take the node A is mentioned and age sequence number will be mentioned in below. Next the age. Next consists of the immediate router. The immediate routers of A are B and D, so it's mentioned. And next is the cost. The cost is 4 and 5. So 4 and 5 is written in the table. Similarly, to all the nodes, this routing table is maintained. Next is distributed link state. Distributing the link state packets. Here, each packet contains a sequence number. They'll keep a track of all the packets. In this table, you can see all the nodes maintain the list of the sequence numbers and to whom they are sending the data. The send flag, which is represented as 1, indicates that the A has sent the data to C and F, and A have to receive the acknowledgement from C and F. Or in other words, we can say C and F have to give an acknowledgement to A. So A is represented as 1. In the similar way, to all nodes, the send flag and the acknowledgement will be mentioned. If it's sending, then it's represented as 1. If not, it's represented as 0. Then computing new routes. Once the router has a full set of link state packets, it can construct the entire subnet using the Dijkstra algorithm. The next is hierarchical routing. Here, routers are divided into regions, and each router knows how to route packets to destination within its own region. In this example, this network is divided into all various subregions. You can see that. Then this table mentions us which region consists of which routers and how many hops it needs. So I hope you paid attention and understood everything. Thank you for watching. And don't forget to like, comment and subscribe and share. And please download our EduMoon app from Play Store, and the link is given in the description box. Thank you.